In this video, we are going to be talking about adding and subtracting radical expressions. To add and subtract, they must be like. Just like with fractions, we have to have like denominators. And with variables, we have to have like terms. We also have to have like radicals. So adding and subtracting, you need to think like, whether it's adding and subtracting fractions, polynomials, radicals, we need to add and subtract like things or like terms. For a radical to be like, they have to have the same index and the same radicand. So meaning a square root can only be added with the square root, and it must be the square root of the same value. So square root of 2 and a square root of 2 can be added, versus a square root of 3 and a square root of 4 cannot be added. So the same index and the same radicand. Remember, the radicand is the number underneath the radical. If they are like, then we would add and subtract the coefficients. And just like when we add and subtract our other like terms, so if I had 1/5 plus 3/5, I would get 4/5. That like part doesn't change. So 5, 5, 5. 3x squared plus a negative 5x squared, we get negative 2x squared. Again, that like part, x squared, x squared, x squared, doesn't change. Same thing with radicals. We add and subtract coefficients, so 5 square root of 2 plus 4 square root of 2. Really, we are adding 5 plus 4, and we get 9 square roots 2. Right? So the like part didn't change. If I tried to add 6 square root of 5 plus 3 square root of 2, I can't, because I have square root of 5 and square root of 2. They're not like. They can't be combined. That's as far as you can simplify that. In this next one, we have to identify the like radicals. So I have a square root of xy, square root of x, square root of xy, square root of x. So I see some like terms with the square root of xy's. I'm going to group those. And I see some other like terms with the square root of just x. So I add only the like radicals. 12 square root of xy minus 4 square root of xy. We take 12 minus 4 and get 8 square root xy. 7 square root of x plus 2 square root of x is a positive 9 square root of x. Now these two are not like, because this has an xy and this is just an x. So that is as far as we can go. Go ahead and try the examples on the right hand side. Okay, part A. 6 square root of 5 minus 2 square root of 5, they are like. 6 minus 2 is 4 square root of 5. In part B, I see this cube root. That is not the same as a square root, so I can only add the like terms here. So that 7 cube root of y stays the same, because it is not like, it has a different index. It's a cube root versus a square root. And then the like terms, 4 square root of y minus square root of y, that's the same thing as saying 4 minus 1. So 4 minus 1 is 3 square root of y. And that's just as far as we can go. So a cube root and a square root are different, just like when we're adding something like 5x cubed minus 2x squared. They're not like. They cannot be subtracted. Same idea with a cube root and a square root. Alright, The next one, I have the fifth root of AB, a cube root of AB, cube root of 2AB, and a fifth root of AB. So looking at that, I see fifth root of AB here, and a fifth root of AB here, and the cube roots are not the same. One has a cube root of just AB, and the other one has a cube root of 2AB. They're not alike. So the only thing we can add here is the 3 times the fifth root of AB and negative 5 times the fifth root of AB. So 3 minus 5 is negative 2, still a fifth root of AB. Everything else stays the same because they were not like terms. And that's as far as you can take that. So, to add and subtract radicals, they must be like radicals, same index, same radicand.